What is black hole? Can we see it? How a black hole forms? Today we are going to talk about that topic which we had thought for at least once. Yes, black hole. Hey guys, welcome to Curiosity and I am Snehashish. Before we start, make sure that you already subscribe to our channel. If you don't, then go and subscribe it. So let's start. Number 1. What is black hole? It is a place or region in space with an enormous amount of gravity. Here, the value of gravity is so much that even light cannot get out of it. Its gravity is so strong because a huge amount of matter compresses or shrinks in a tiny space. These are some frictional images which are imagined by scientists. In 1783, Professor of Cambridge University John Michel described black hole. After that, in 1796, Pierre Simon, a French scientist, described briefly about black hole in his book The System of the World. Then, in 1916, Albert Einstein predicted the existence of black holes with his general theory of relativity. Number 2. Can we see a black hole? As even the light cannot get out of a black hole, so we cannot see it. But many of you think that then how scientists capture the first image of the black hole? Well, they use EHT or Event Horizon Telescope for capturing the image of the black hole. Number 3. How black hole forms? Before we start, we have to know the types of black holes. Generally, there are two types of black holes. One is stellar black holes and second is supermassive black holes. Stellar black holes, small but deadly in nature. When a star burns through the last of its fuel, the star collapses into itself. For smaller stars, that means those stars up to about 3 times the sun's mass, the new core will become a neutron star or a white dwarf star. But when a big star, that means those stars who 20 times greater than or equal to the sun's mass are collapses, it continues to compress and creates a stellar black hole. These type of black holes are relatively small but incredibly dense. A stellar black hole can be more than 3 times of sun's mass in diameter of a city. This could have an enormous amount of gravitational force. Stellar black holes consume the dust and gas from their surrounding galaxies, which keeps them growing in size. Next is supermassive black holes. These black holes are millions or even billions of times massive than our sun. Supermassive black holes may be the result of hundreds or thousands of small black holes that merge together. Large gas clouds could also be responsible, collapsing together and rapidly exerting mass. Collapsing of a stellar cluster, a group of stars that falls together, these black holes are thought to lie at the center of every galaxy, including our Milky Way galaxy. In a black hole, there are 6 parts: singularity, event horizon, photon sphere, relativistic jets, innermost stable orbit and accretion disk. Singularity. At the very center of a black hole, matter has collapsed into a region of infinite density called a singularity. All the matter and energy that fall into the black hole ends up here. The prediction of infinite density by general relativity is thought to indicate the breakdown of the theory where quantum effects become important. Number 2 is event horizon. This is the radius around a singularity where matter and energy cannot escape the black hole's gravity, the point of no return. This is the black part of the black hole. Photon sphere. Although the black hole itself is dark, photons are emitted from nearby hot plasma. in jets or an accretion disk. In the absence of gravity, these photons would travel in straight lines, but just outside the event horizon of a black hole, gravity is strong enough to bend their paths so that we see a bright ring surrounding a roughly circled dark shadow. Relativistic jets. When a black hole feeds on stars, gas, or dust, the metal produces jets of particles and radiation blasting out from the black hole's poles at near light speed. They can extend for thousands of light years into space. Next is innermost stable orbit. The inner edge of an accretion disk is the last place that material can orbit safely without the risk of falling past the point of no return. Now, accretion disk. A disk of superheated gas and dust whirls around a black hole at immense speeds, producing electromagnetic radiation like X-rays, optical rays, infrared and radio waves that reveal the black hole's location. Some of this material is doomed to cross the event horizon, while other parts may be forced out to create jets. That's all. Now, the most important question: will our sun ever turn into a black hole? Well, the sun doesn't have enough mass to collapse into a black hole. In billions of years, when the sun will at the end of its life, it will become a red supergiant star. Then, when it was used the last of its fuel, it will become a cooling white dwarf star. So I hope you like today's video. If you like this video, then click the like button and also subscribe to our channel. If you want to read more about black hole, then go to our website Scientific World. The link is given in the description box. If you think that our site is helpful to you, then support us by subscribing to our site and follow our site. Thank you.